For this review problem, let's take a look at this indefinite integral from 0 to infinity of x e to the minus 2x to determine if this converges or diverges. And if it converges, we need to evaluate the integral. To begin, we use the definition of a indefinite integral from 0 to infinity, x e to the minus 2x dx. That is equal to the limit as b goes to infinity of integral from 0 to b of x e to the minus 2x dx. Okay, now we will compute this integral here, and then we will deal with the limit of pretty much the very last step. So for the next few steps, we're going to work with this integral, and then this limit here is just going to come along for the ride until we get to that very last step. All right, so to do this integral from 0 to b x e to the minus 2x, we will use integration by parts. And I see that I have an algebraic expression here. And so using the acronym ILATE, I don't see any inverse functions. I don't see any logarithms. I do see an algebraic function, and the exponential function comes last. So I will let u be equal to x, and therefore du will be equal to dx. And for the other part of this expression, we have that dv is equal to e to the minus 2x dx. And so integrating, v would be equal to negative 1/2 e to the minus 2x. Okay, so putting the parts together, we have limit as b goes to infinity. And I'm going to keep that in red just to emphasize that that is going to come along for the ride until the very last step of the integral from 0 to b of, okay, so now I've written this as u dv. And so this will be equal to the limit as b goes to infinity of, okay, so according to the formula for integration by parts, we have u times v minus the integral, evaluate from b to 0, minus the integral from 0 to b of v du. And again, the limit I will deal with on the very last step. So limit as b goes to infinity. Okay, so now let me get rid of the blues and red, greens and just do the substitution. So we have x times negative 1/2 e to the minus 2x, so minus 1/2 x e to the minus 2x, evaluated from b to 0, minus integral from 0 to b of v, so negative 1/2 e to the minus 2x times du, which is dx. Okay, so plugging in here, we have a limit as b goes to infinity. So plugging into this first part, we would have minus 1/2 b e to the minus 2b minus, and then when I plug in 0, I would just get 0 because of the x that's right here. Okay, so that's what I get for plugging in. Over here, I get plus 1/2 integral from 0 to b of e to the minus 2x dx. Okay, so limit as b goes to infinity. Inside here, I have minus 1/2 b e to the minus 2b. And then this last part here, I'd have an extra negative 1/2 that comes out. So I have minus 1/4 e to the minus 2x from b to 0. Okay, so we're almost ready to take on that limit. Limit of negative 1/2 b e to the minus 2b. Then subtracting, we get 1/4 e to the minus 2b minus. And then if I plug in 0 this time, I get 1/4. because 1/4 e to the 0 is equal to 1/4. Okay, now finally, we're able to take on this limit. So let me switch to all black now. Limit as b goes to infinity. These terms I'll combine as -1/2 b minus 1/4 all over e to the 2b. And then I've got an extra plus 1/4 that comes along that's not part of that fraction. Okay, now this can be evaluated with L'Hopital's rule. I also have the convenient limit that this is going to be 0. Let me apply L'Hopital's rule just for the sake of practice, but I know this is going to be equal to 0 because it's a polynomial divided by an exponential, and exponential growth will always beat polynomial growth as b goes to infinity. For the sake of practice, let me do the L'Hopital's rule on this. So the 1/4 I'm going to bring outside because I know that's just 1/4. I apply L'Hopital's rule to this fraction. So limit as b goes to infinity of -1/2 over 2e to the 2b. And as b goes to infinity, now this was in the form infinity over infinity. This is now in the form of something over infinity. So I no longer apply L'Hopital's rule. I get -1/2 over infinity. That goes to 0. The denominator here goes to infinity. The fraction here, therefore, goes to 0. So this is equal to 1/4 plus 0, which is therefore equal to 1/4. And so that is the value of the integral. And so obviously the integral converges. The integral converges, and not only does it converge, but we actually found the value of the integral that's equal to 1/4.